we're doing today is everything we've done up to this point. Okay, so we are going to be doing algebra stuff like finding asymptotes. We are going to be doing limit stuff like finding asymptotes. We'll do some x and y intercepts. We will do increasing, decreasing, max, min, concave up, concave down, inflection points. Throw it all together and we'll have a graph. Okay, so essentially that's all it is. So this is guidelines that say exactly that. It says determine domain and range of the function. Essentially, you're looking at intercepts and you are looking at asymptotes. You don't have to actually write out the domain, but all of that will kind of come in to here. And then we will do our increasing, decreasing, points of inflection, relative extrema. It doesn't say increasing, decreasing, but that is implied in here. And it doesn't say concavity, but that is implied by saying points of inflection. Okay, so it is included in that list. So if you were to do a checklist, 2 and 3 are the most important as a checklist of what we'll do. All right, so I'm going to attempt to fit this all on one page, but just keep in mind, what you guys are writing on notes, you might have a little more space than me. In some ways, it depending on how you zoom. Maybe I'll zoom. Maybe I'll do that. Okay. And then I can move over. Okay. So we have the function 2 times the quantity of x squared minus 9 over x squared minus 4. So what I would like to do first is I would like to start with our x and y intercepts. So we will first find our x intercepts. I'm going to abbreviate it as that. Okay. You find x intercepts by allowing y to be 0, which means we're letting that whole fraction equal 0. But fractions are only equal to 0 when the numerator is equal to 0. So really, I only have to worry about solving this. And even that 2 out front is kind of silly, because if I divide the 2, both sides by 2, it's then gone, and I'll be left with this. So you could even almost jump to just that if you wanted to and get that x-intercept. So if I add 9 to both sides and I square root, I will get 2 answers, because when you square root both sides, you get a plus and a minus, and I will get plus and minus 3. Very good. So I'll hold that there. I'm going to circle. I like to circle as I go. I circle everything because I have to find it again later and put it on a graph. So I don't want to lose it in all the information that we have. Okay. On your homework, I did provide you grids. Okay. For notes, we're just going to have to muddle through. All right. So then let's do our y-intercepts. How do you find y-intercepts? We're going to let x equal 0. So we will do y equals instead of f of x equals. And then we'll do 2 parentheses 0 squared minus 9. You can probably do a lot of this in your head. But we have this, okay? So it's not the prettiest of things. But I'll have negative 18 on top, and I'll have negative 4 on bottom. And that reduces to 9/2. Or it might be helpful to do it as 4.5 when you're graphing it. So there's our y-intercept. Okay, so we're still in algebra land, doing stuff like that. Continuing on to algebra land, let's do our vertical asymptotes. I'm going to call them VAs. Okay, so a vertical asymptote happens when your function, where it doesn't exist. So I write in parentheses here to help you guys out. Let's do set denominator. I'm going to abbreviate denominator into denom equal to 0. So that's your hint. So for your vertical asymptote, that is what you're always going to do. Okay. So we're just going to look at where it is undefined. X squared equals minus 4 equals 0. And I will get 2 vertical asymptotes of -2 and 2. So there's your vertical asymptotes. So we'll hold on to those for later. So those are the equations of lines. When we graph our asymptotes, we'll graph them dotted. Now you'll do next horizontal asymptotes. If you don't get a horizontal asymptote, then you have to test for what's called an oblique asymptote. Okay, so we're going to use the calculus way to find horizontal asymptotes, because if you recall from who knows when in your background, Hopefully it existed, but you just had to memorize like, oh, if the degree on top was bigger than the degree on bottom, you had this. If they matched, you did this. If it was vice versa, you did this. Well, the reason that is when you do horizontal asymptotes, you are always going to do the limit as x approaches infinity of the function itself. So we will have 2x squared minus 9 all over x squared minus 4. So then you have to recall something from chapter 1, I believe, which is how to do limits as x approaches infinity. Okay. So I'll just remind you, and then when it shows up on a test or something, you'll have to remember it. But it is that method where we divide all terms by the greatest power of x in the bottom. So I'm going to go and divide this by x squared, this by x squared. You can or cannot distribute that 2 through. That's kind of up to you. It doesn't affect the power of things. I'm going to squeeze that in there, x squared, x squared. And so that I'm left with the limit as x approaches infinity of 2 times 1 minus 9 over x squared and 1 minus 4 over x squared. Now I can plug in infinity because you can't have infinity over infinity, which is what would have happened before. If I plugged in infinity, now I can plug in infinity. When I plug in infinity to 9 over x squared, I get 9 over infinity squared, which is still just 9 over infinity. But do you recall anytime the denominator is just like enormous, the whole number goes to 0. So if I divide by infinity, this is 0. Likewise for the 4 over x squared, that will end up being 0 because you have 4 over a gigantic number. So then all that's left is 2 on top, 2 times 1 on top, but 2 on top and 1 on bottom. So our horizontal asymptotes are y equals, is the line y equals 2. Okay. Now, if that came up with like does not exist or undetermined, you would have to then go do an oblique asymptote, which is where you have to actually do the division. Okay, so what we'll do is if you don't have a horizontal asymptote, you'll do that. We'll do a problem like that to remind us how to do it. So we don't have to worry about oblique asymptotes right now. Sometimes I call them slant asymptotes because they are slanted. All right, so that is all of our algebra, pre-algebra stuff. And now we're going to go into our increasing and decreasing. Okay, so how do we get increasing and decreasing? Max and min, we do our first derivative. So f prime of x equals. For the sake of this, I'm going to distribute. That's my numerator I'm going to deal with because I don't want to chain rule unnecessarily. And you could have done that from the beginning if you had wanted to. So I'm going to chain rule. So we have to do the quotient rule. So we will do the denominator, low d high, times the derivative of the top, which is, it's not 2x, it's 4x. Hold on, I'm going to cross this out so I don't look at that. 4x. And then minus high d low, which is the top, 2x squared minus 18, times the derivative of the bottom, which is also a linear term, all divided by the bottom squared. Okay. Go ahead and simplify the numerator. So distribute your 4x through that first binomial and distribute that 2x through that second binomial. And then we'll also combine our like terms. I'm going to try and do it in my brain. Very nice. Do you get that? Okay, awesome. So it's kind of nice that that cubic term canceled because we have to solve this to put numbers on number line, and that would just make it harder. Okay, so then now we need to figure out where it's equal to 0 and where it's undefined and test around it. So now look at the denominator. Where it's undefined probably is obvious that it's 2 and negative 2. We already know there's asymptotes there, so those can't be max and min. We still have to figure out what's going on around them, so we'll still test. but just keep in mind, they don't actually exist there. Okay, so when I solve this, I solve the top, and I will get x equals 0, and then x can't be positive and negative 2. Okay, and I like to try to preface that because we can't have max and min there. Now I will put them on a number line. And I will have -2, 0, and 2. And I will pick values to the left of -2. Let's do -3. Let's do -1, 1, and 3. Okay. You really can pick whatever you want, but let's not get too wild. Okay, so then we have to figure out where to plug those in so that it's most useful. And we're just looking for sign. I just need to know whether it's above 0 or below 0, positive or negative. So you can plug it into this entire thing here. Or anyone know else we can plug it in that might be easier? Just the top. Just the top. Because the bottom is always positive because it's squared. So we just have to multiply it by 20. So essentially whatever sign it has, it still has. Okay, so that's kind of nice. Yes, ma'am.
I have a few questions.
Absolutely.
So say it was like cubed on the bottom.
Yeah.
Then you plug it into the bottom.
And the top.
And the top. Okay.
Yeah. Yeah. So if it had an odd power in the bottom, you would have to probably plug it in the whole thing. Okay. So we're grateful for even powers, so we don't plug it in as much. So since we're just multiplying by 20, 20 won't change the sign. If it was -20, it would change the sign, but since there's positive 20, so 20 times -3 is negative, and 20 times -1 is negative, and 20 times 1 is positive, and 3 times 20 is positive. Okay, so this is probably the first time we've seen one that wasn't super alternating. Because it's not. We haven't gone in the same direction. But that might make sense. We have our asymptotes. It can go in the same direction and then start going that same direction again because it's going to stop at -2. Or not stop. It's going to be limited by -2. So let's go ahead and we can have a minimum, if you notice, here at 0. So we'll have a minimum at 0, comma something. Even if we had alternating, that -2 and 2, I know I've said it like 5 times, but I just want to reiterate, couldn't be a max and min no matter what. And then let's go ahead and do our increasing intervals and our decreasing intervals. Okay. So how do you obtain the value for your minimum, your ordered pair? Plug it into the original equation. Okay. What do you get when you plug that into 2x squared minus 9 over x squared minus 4? It's a number we've seen before, 4.5. And that kind of makes sense because if 0 is its x-intercept or is its x value, then it has to be a y-intercept by definition. Okay, so increasing, where is it increasing at? Starting at 0, and it stalls. It's still continuously increasing, but it doesn't exist at 2. So you can't make it a continuous interval because it's not continuous. So we have to do 0 to 2 and 2 to infinity. Now, if it existed at 2 and it just had a stop, you could combine it. You should combine it at that point. All right, and then decreasing, it is decreasing from what starting place? Negative infinity, and it stalls at -2. And then we also do -2, and it stops at 0. Okay? Good. All right. Let's see how much space I have. Oh, this is going to be interesting. Okay. So now we need to do our, hold on, I'm going to circle that. I don't want to lose that information. We need to do our second derivative. I'm going to start a little lower just so I can put a coordinate plane up there on the right. So second derivative. We'll go from that place I put this arrow earlier. We'll do our low d high from here. Okay. So we will do our low d high, which is just 20. Hold on, I got to scoot mine over. You guys keep going. I should have done it on the notes like you guys have. keep that in mind for future. F double prime of x is equal to low d high minus high. And you have to chain rule that denominator. Oh, I'm running out of so much space. You guys have to make sure I don't mess that up. That tiny 2x is intended to be multiplied in my numerator. All over the bottom squared. Okay. And I mentioned it the other day, but don't FOIL out that denominator. One, it's super ugly because to the fourth power, so it's going to be enormous. But also, do you see that both terms in the top have an x squared minus 4? And then the bottom has an x squared minus 4. So we can actually, I'm going to do it in different colors so we can kind of see it better. I'm going to take out this guy entirely and one of these guys, and I'll cancel it with 1 in the bottom. Do you see how that would work? That's like everybody having a 2, and I'll just cancel it out. Okay. If you need to write it pulled out, you can. Okay. The only reason you can do that is because it's multiplied into every term. Now, we rewrite that a little bit. And if you are super algebra, like gung-ho, you can kind of distribute as you go, which is what I'm going to attempt to do. So I'm going to do 20x squared minus 80 minus, so we have a 2, 80. Is it 80x squared? Okay. I got a nod from somebody, so that's helpful. And then our worst nightmare is an odd power, which means when we plug this in, we potentially will have to actually plug in numbers. So, all right, simplify the top more so that what's all that's left is it negative 60x squared minus 80 all over x squared minus 4 all cubed. Okay, so we have that super ugly thing. If you wanted to factor out like a 20, a negative 20 in the numerator, just for the sake of having it factored out, you can. It might be helpful in the long run. But for now, what we need to do is solve it. So figure out where it's undefined, which we already know x can't be 2 and negative 2. But when I solve the numerator, set the top equal to 0. So we'll do negative 60x squared minus 80 equals 0. What do you get? Mm-hmm. All right, it's a little bit amusing. Don't overthink it. If I add 80 to both sides and I divide by negative 60, I get a negative number on the right equal to x squared. If I square root both sides, it's undefined, or it's not undefined, it's imaginary. And so there is no place where this actually happens at. So we're only testing around 2 and negative 2. So there's going to be no points of concavity because it doesn't exist there, but it can still help us with its shape, where it's happy and where it's sad. So we will still put on a number line. Just keep that in mind. You would normally find points of concavity as well, but since there's no place that actually exists, we won't this time. So we'll just test around negative 2 and 2. So I'm going to pick negative 3, 0, and 3. And unfortunately, there's not a super great place to plug this in where it's going to be simple. So we'll have to plug it into basically that entire thing and look for signs. So there's that. The top, actually, what's helpful, the top is always negative. Okay, it will always be negative because you factor that negative 20 out. The other thing is always positive, so the top is always negative. So that is helpful. So just keep in mind, we just plug it in the bottom and then change its sign. That can be a way to do it, a little shortcut. So I plug in negative 3 in the bottom, 9 minus 4. It's positive, so I'll end up with a negative when I do that. And then I'll plug in 0, and 0 is pretty easy. And we will get a negative on the bottom, but then also a negative on top. So it'll be happy. And then plug in 3, and because the squared thing, it will kind of mirror with a negative 3, and it'll be sad. So we will have no points of inflection, but we will have concave up intervals and down intervals. So where is it concave up? It's happy from -2 to 2. And then it is sad from super far left, -infinity, to -2. And then also from 2 to infinity. Okay, so we have all this information. So now I'm going to zoom out so I can see all my information. I should have probably zoomed in more. And we have to graph all this stuff. Oh, goodness, is exactly right. Well, where the heck am I going to graph this at? I'm going to attempt to graph mine here. Fortunately, the numbers aren't super big. Like, we have 4.5 is, I think, the biggest number I see. If you can't, when you plot the information we have circled, if there's not enough information for you to get a shape, then you can do an XY chart and kind of fill in where you need stuff for. Okay, so let's start with our x-intercept. So we have positive and -3. So 1, 2, 3. 1, 2, 3. And I should have put a grid on here for us, but I didn't. Sorry. Y-intercept is 4.5. 1, 2, 3, 4. Vertical asymptote, so we'll do these with dotted lines, is -2 and 2. And then horizontal asymptote is y equals 2, another dotted line. So if you notice, we have like 6 quadrants that we've kind of developed with our asymptotes. So that's kind of interesting. When we do our graphs, we have to make sure we don't cross those. There are very rare occasions where you cross an asymptote. We won't get into that, but it does happen from time to time. All right. Let's start with our minimum. We already have a graph. The minimum is the y-intercept, so done. Increasing, decreasing is from 0 to 2. So is increasing from 0 to 2. So in this area, I'm going to do it dotted to start off with. I'm going to do a different color. It is increasing here, okay? It's a rough sketch on that line. I am not intending to have any concavity with it at all. Okay, just so I know what direction it's going. And then it's also increasing from 2 to infinity, which is in this area here. So we'll have to make sure that is going up, okay? And then we have decreasing from -infinity to 2. So everywhere left down to that asymptote will be going downhill. With the concavity, it'll make a little more sense. And then it is also decreasing here. Okay, so that's what we have. Concavity will help us a lot. It is entirely happy in that middle area. And you can kind of see that. It is going to be so happy here because it's concave up between -2 and 2. So you can add some curving to that now where it's happy. But it is not crossing either asymptote. It is sandwiched in between there. Okay. And then we have concave down, which means it'll have to curve downward somewhat from -infinity to -2. Where's my pen? There it is. So that means it's going to be going down and looking down like it's kind of angled downward, but it still can't cross those asymptotes. So it's going to be super, super close to that y asymptote, the horizontal asymptote, and getting super, super close to that x asymptote, but it's never crossing it. And then likewise, this is also concave down. So it's starting from this, but it still has that curve down look here, but never crossing those asymptotes. So you have a curve on the left, a U in the middle, and a curve on the right. Does that make sense? So next time, I think I'm going to zoom in more, and then I'm going to have my graph be big. I should have done it on your guys' notes. Any questions on that process? So there's not really anything new. It's just kind of putting it all together. All right. What time does our bell ring? Ooh. Okay, we'll get started on this, but there's no way we're going to finish it. Yes, Alex?
Since the bell's gonna ring soon, can we do the last question?
The last question?
Because it's like how to make the graph. Yeah. answer?
No, I want to go in order. It'll really bother me if we don't go in order. So let's just get started on some of the algebra on this, and then hopefully tomorrow we'll be able to finish it. Okay, I'm going to zoom in like nobody's business. Okay, so we have the function x squared minus 2x plus 4 over x minus 2. So we are looking at x-intercepts first. And you find x-intercepts by finding out what it is, what x's make it 0. So I set the whole thing equal to 0, but fractions are only equal to 0 when the numerator is equal to 0. So we've got to consider where this is going to happen. Okay, so you could try to factor it. It's not factorable. So then we could try the quadratic formula. And before you really go into full quadratic formula, you should do what's called the discriminant. Yeah. And that is just the inside of the root part. So you have your negative b plus or minus square root of b squared minus 4ac all over 2a. It is just that b squared minus 4ac. Okay. If that is a negative number, there's no solutions. If that is a positive number, there's 2. If that is 0, there's 1. And so I'm just going to do b squared, which is 4, minus 4ac, which is going to be 16. So you have 4 minus 16, which is a negative number. So there's actually no way that will ever be 0. So there are no x-intercepts. So we'll move on to our y-intercepts. And y-intercepts are what we said earlier is where you plug in 0 for x. And so this one actually works out pretty nice. I'll do 0 squared minus 2 times 0 plus 4 all over 0 minus 2, giving me 4 over negative 2, which is negative 2. So I have my y-intercept of negative 2. That's all I have there. Then we can do our vertical asymptote, and do vertical asymptotes by figuring out where it's undefined. And if it's a fraction, it automatically could have a potential for being undefined somewhere, and that's where the bottom's equal to 0. So we would solve this because it can't be 0, and we would get a vertical asymptote of x equals 2. Does that make sense? Okay. Then we'd have to go and do our horizontal asymptote. I feel like this is easily forgotten, but it's where the limit as x approaches infinity. So you'd have to train your brain to do it that way. But the limit as x approaches infinity of that whole thing, x squared minus 2x plus 4 all over x minus 2. And if you recall, in order to do this limit, you're going to divide all parts by the greatest power of x in the denominator. In this case, that is x. I'm going to divide everything by x. So that I have x minus 2 plus 4 over x all over 1 minus 2 over x, and I forgot my limit as x approaches infinity. Now, when I go plug in infinity, this is 0, this is 0, but if you notice, I'm going to end up with infinity minus 2 over 1, which is infinity, which means there's not a horizontal asymptote, which means there is an oblique asymptote or a slant asymptote. I'm going to call it OA, and we're going to leave you on a cliff there